Hi everyone, in this video I'm going to look at matrix multiplication in Mojo. I think they handpicked this example and implemented in a way that be as slow as possible. And let's see. First of all, they created a data type matrix which exists in NumPy. We don't need to create this one. And when they want to place the data inside of matrix, they use a dynamic type list. And this list is it can be appended or be any size, but here we know the size of data predefined. No need to use this data structure. And then they used a random module to create random numbers, and this API gives us a float 64 numbers, but when they implemented their own matrix they used float 32. We know that matrix multiplication is something that can be optimized by using correct data types because it's heavily dependent on the cache hits. When you use bigger data types like float 64, you miss cache more frequently. And yeah, they used float 64, and to be fair they divided their time by 2, but we know that this is not fair. And again, when they wanted to compute this benchmark gigaflops, they used a smaller matrix size compared to what they used for their own version of matrix multiplication, which I think is not fair again. And yeah, these are at least things that I think make this Python implementation worse. Let's test it against what actual Python code look like. We create our NumPy. Let me run it first because it takes some time, and then I'll explain this implementation. Okay, we simply can use matrix multiplication operator between two NumPy in the arrays, and we need to initialize them as a correct type, and we don't need to divide the result by anything. It is what it is in the Mojo version. I think why this is not running, let me restart the kernel and run all cells again. Yeah, it's running now. And if we run the notebook again, we can see that we get 60 gigaflops with this simple implementation compared to what they said that is gigaflops of writing some matrix multiplication in Python. Yes, you can even make it worse. You can simply place some slip in your every function and make it worse. Let's go to the end of notebook to see how actual speedup is against Python. Thanks for watching. Bye.